and that was a scientific research group that was focused mostly on radiation and its biological effects. This was a very big worry in those days because atomic weapons, when they explode, do a number of things. One of them is to release huge amounts of radiation, and this can be very deadly. And the Hiroshima and Nagasaki bombs, much of the damage they did to the Japanese was direct radiation from the explosion, from the fission event. And just how this works, how this works biologically, was poorly understood, but somewhat understood. And people who'd gotten hurt by nuclear radiation before World War II, and before before fission was discovered, which was 1939. Marie Curie, who is famous for her work with radium and uranium in the 20s and 30s, died of radiation damage that she suffered in those very early radium and uranium experiments. And at that time, very little was known about it, and so she was unconsciously a guinea pig for a big radiation experiment. So the damaging effects to people and all living things of radiation, high energy radiation like gamma rays, X-rays, and particle radiation like alpha rays and beta rays, was a big concern, and that was one of the main focuses at the lab, in the biomedical research group that I worked in. And one of the effects that became known early on of radiation on people was damage to cells and cellular content, especially DNA. And this was, so the biological effects of radiation turned out to be an area of cellular and genetic biology, and that's what the research group that I joined was focusing on. So that was a general area that the biomedical research group worked in.